So today we're going to get into lesson 4.2, which is over slope of a line. So in the previous section we talked about graphing linear equations, and now we're going to talk about what slope is and how we can find slope of a line. So first, in order to know or how to find slope of a line, we have to know what slope is. So this is your slope definition. So slope is represented by m. So in an equation or in a whenever you see the variable m, you're going to think that is slope. Okay, m represents slope. Slope is represented by the letter m. The slope of a line is the ratio of the change in y, which is your rise on a coordinate grid, which we'll talk about. So it's your rise or drop, same thing. So rise to the change in x, which is your run, between any 2 points. So again, that's very important to understand. First of all, these are written in fraction form. Obviously they can be reduced to become whole, like they can, be reduced to like work out to be whole numbers. But again, it's a ratio of your change in y, so your change in y is on the top, and then your change in x is on the bottom. And again, these are two important words, rise and run, because you'll see the ratio of rise over run as well to describe slope. Here's a better interpretation or a better picture of what that is going to look like. So this is basically what I just said, but it's more in the equation form. So this is something also to make sure you remember. So this says m equals y2 minus y1 over x2 minus x1, which is exactly what that last slide said. It's your ratio in the change in y over the change in x. Change in means you're just subtracting your y values and then subtracting your x values. Some of you might have never seen these little numbers like in the bottom right corner. You've seen them in the top right, which are exponents. The bottom right, they're called subscripts, and they are used to just denote different y values. They don't have any, like with exponents, you are multiplying by yourself however many times. They don't have any multiplication or any like operating powers. Like they're just there to tell you that there is more than one y, more than one x. Okay, so don't worry about using those numbers. It's just telling you the different y's and different x's. And again, this is the same thing as your rise over your run. And I'll show you what that means on a coordinate grid, but you're talking about how much you're going up and down over how much you're going left and right to get to those points. So let's look at what this might mean. First, we need to understand the different types of slopes. You have slopes that run uphill, slopes that run downhill, slopes that are horizontal, and slopes that are vertical. So if it's running uphill from left to right, it's going upwards, that is a positive slope, which makes sense. If you're going up, that is going to be a positive slope. So left to right going upward is a positive slope. Next, downhill, if you're going left to right downwards, you have a negative slope. Okay? And that makes sense, and I'll explain why. Horizontal, you have a slope of 0. So anytime you have a line like this, you have a slope of 0. And then lastly, you have a vertical line. If you have a vertical line going straight up and down, the slope is undefined. You cannot define that slope. Personally, I like to break these down a little more just to make sure students understand it, because I think when students can break a problem down and know the actual basis of it, they understand the concept a little more. So like, for example, going back to the rise over run, like on a graph, what that means is, like if I have 2 points on this line, one here, one here, if I'm going from this point to that point, I do my rise first. So I'm going, again, you don't need to know coordinates for this. It's more than anything just showing you that it's a positive slope. And we'll get into like ones with coordinates. But for here, if I have a rise first, I'm going upwards to get to that point. I'm going up, so that would be positive. If I'm going up, it's positive. And then I have to go right to get to the point. And again, right on a coordinate plane is also positive. So rise over run means I would have a positive number over a positive number. So obviously that slope would be positive. And you can think, okay, well what if I go a different way to get to it? If I go right and then up, it's still, If I go right, it's positive. If I go up, it's positive. Again, you want to do your rise over run first. That's why I went this way instead of the other way, because you want to rise first, then run. What if you start at this point? This is where students will get confused too. They say, well, what if I want to start at this point and go to this point? Okay, you can do that. That's fine. But now I'm going down, and you're like, well, that's weird because now that's negative. You're right, that is negative. But then I also have to go left, and left is also negative. So if I take a negative number over, this is my rise over my run, negative over a negative, that equals a positive. Because a negative divided by a negative is a positive. So either way, you get a positive slope when you're going this way. So let's look at this one. We have a negative slope, and I've got 2 points. If I want to get from this point to this point, I'm going to go right first. Or sorry, let me start. I need to go rise over run. So if I'm doing rise over run, I need to do my up or down first. So that means I'm going down first, down, which is negative. That's my rise. And then run, I'm running right, which is positive. So therefore, if I put that in a rise over run form, it would be negative over a positive, which equals a negative. So that's why it has a negative slope. All right, so next, slope of 0 is my horizontal. Let me show you why that is the case. So first of all, let me do my rise. My rise, I don't rise at all. I stay on that same plane. So there's no rise. So my rise would be 0 over, and then I run this way or this way. It doesn't matter. You can run right or left. Either way, whether this is a positive or a negative, actually let me write that as 2 separate equations, or 2 separate fractions. So if it's a positive or if it's a negative, 0 divided by any positive number is 0. 0 divided by any negative number is 0. So that's why a horizontal line has a slope of 0. And then lastly, we have this. We have 2 points on a vertical line. Again, we do our rise or run rise first. So I can start from the top point and go down. That would be a negative number. Or I can start from the bottom point and go up. That would be a positive number on the top of my fractions, because it's rise over run. And then you realize you don't run at all, meaning you don't move left or right at all. So that means the bottom number would be 0. And this is why slope is undefined for a vertical line. Anything divided by a 0 is undefined. Okay, you cannot define that. So that is why any number divided by 0 is undefined. So that's why we have a slope of undefined. If you plug it in your calculator, any number divided by 0, it'll probably pop up as an error. So that is just a little more explanation of why those slopes have the slopes that they do. So let's go ahead and jump into some examples of this. So I know these are just ordered pairs, but these are the type of examples I want to plot first. So we have negative, so go ahead and make sure you write these down, and I'm going to move over to the coordinate grid to plot these. Okay, so let me get this camera moved over. Hopefully you've written down those points. I'm going to move this over so you can see it on a coordinate grid. So the first number was -3, -1. So when you plot that, your first number is your x value. So you go left to -3, because you're moving this way first when you plot points. So left to -3 and then down to -1. That's your first point on this. And my other point is 3, 4. So I move right 3 up to 4 on the y-axis. That's my other point. All right, so I'm going to go ahead and make this line. So this is the line that was represented by those 2 ordered pairs. Okay, so first of all, it wanted us to describe the slope, meaning which of the 4 in that last slide would this represent. As you can see, from going from left to right, this is going uphill, So to describe it, this would be a positive slope. So before I even work anything out or do any work, I know it's a positive slope. Okay, so then from here, I'm going to use these 2 points to find the slope of this line. And again, you want to use, usually it's easier if you go from the left point to the right point. Technically either is correct, but for me I'm going to start here and go to this point. So if I do that, you have to first, again, it's rise over run. Your y value is how much you go up or down, and then your x value is how much you go left or right. So I'm going to start here and count how many I have to go up to get on this same plane of my other point. And if I do that, it's 1, 2, 3, 4, 5. Okay, so 5 got me to right here. So 5 got me to right there, where I need to be. So that means as a fraction, or as my slope, 5 is my rise. That's my top number. And again, I went up, so that's positive. So then from here, I'm going to go and see how many it takes me to get to my point, going right. So that would be 1, 2, 3, 4, 5, 6. So 6 to the right got me to the point. So that means 6 is my run. And again, it was on the going in the right direction, so that's a positive number. So my slope of this line is 5/6. That is what the slope is. So m equals 5/6. Because remember, m is your slope variable. So m equals 5/6. Okay? So let me get the eraser. We're going to look at the next one. It gives us the points -1, 1. So again, to plot that, I go left 1 on my x, up 1 on my y. That's my first point. And then 1, -2, right 1, down -2. And I'm going to connect them with the straight edge. So this is my line that we're looking at now. Again, first thing it wants us to do is describe the slope. So as you can see, going from left to right, this is running downhill. So this would be a negative slope. So we know that whatever, we don't know what the number is yet, but we know our final slope is going to be a negative number. So I'm going to start on this point and go to this point. Again, you want to do your rise first, meaning going up or down. So to get from going up or down, get from here to here, I'm going to have to go down. So I have to see how many times I have to go. So 1, 2, 3. I had to go 3 to get on the same plane. And I went down, so that is a -3 is my rise. Okay, -3 is my rise. And then I have to go to the point 2 spots to the right. 1, 2 to get to the actual point. So since I went right, that's positive. So that is 2 on the bottom. So this negative sign can just come out in front. So that means my slope is m equals -3/2. So that is my slope. And we knew it was going to be negative because it's going downhill. So the slope is m equals -3/2. Okay, so that's how you're breaking down on a graph how you can find these slopes. I'm going to leave the camera there just so I don't have to move it back and forth. But I have another one on the board that I want you to try. I want you to find the slope of -1, -2, and 2, 2. So I want you to find the slope, take a second, pause the video, try and graph those, and find the slope. First describe the slope, then find the slope of that line. And again, I know it's hard to see on this. This is -1, -2, and 2, 2, if you can't see that. So, hopefully you pause the video and try this. I'm going to go ahead and plot these. -1, -2 means I go left 1, -1, and down to -2 on the y. So there's my first point. And then 2, 2 means I go right 2, up 2, and there's my other point. All right, so I'll go ahead and connect these. Make a line through them. Looks like that. So again, first of all, you see this is running uphill, so that should tell you to describe it, it is a positive slope. This is going to be a positive slope because it's running uphill. All right, so next I'm going to go from this point to this point and find the slope of this line. In order to do that, first I do my rise. 1, 2, 3, 4. So I rose 4 to get on the same plane as my other point. So the first number in my slope is 4 on the top. Over 1, 2, 3 to the right. And to the right is positive, so that is a positive 3 on the bottom. So my slope of this line would be m equals 4 over 3. Okay, so that is how you find the slope of graphs. Okay, if they give you a graph with a line on it, you can just do rise over run to get the slope of that line. So let's also look, we're going to look at how we can find the slope when we're just given points and we don't have to graph it. Okay, let's move back over and look at how that will be done. Okay, so here's another example that just wants us to find the slope. We don't have to graph it. We can actually do this by just breaking down these problems because we're going to use that equation from a few slides ago. This equation is something you need to make sure you memorize. y2 minus y1 over x2 minus x1. I have students get this confused all the time, I promise. And if you're not careful, you will as well. Your y's go on top and your x's go on bottom. This has to be something that is just in your brain that you can remember all the time. So, the way to label these, you're going to label each of these ordered pairs. You know in ordered pairs that x values come first. So, this is an x, this is a y, this is an x, this is a y. So we know that. And then all you're going to do is you can label, this is my first ordered pair, so this is x1, y1. This is my second ordered pair, this is x2, y2. That's how you label these points. You have to label them in order to plug them in to here. So make sure you're careful when you're doing that. Once those are labeled, you're able to plug them straight into this equation. So what that will look like is, I start with y2. My y2 was 5. So that's what I plug in for y2. 5. Minus, make sure you write this minus sign down before you even look what the next one is, because sometimes students, 8th grade students a lot, mess up their minus and negative signs and they get that all confused. So make sure you just write the y2 minus, and then I'm going to go look what the y1 was. It is 5. So 5 goes in the y1 spot. x2, I look over, x2 is 6, so 6. And again, I'm going to write my minus sign before I even look what the x1 is. So minus, and then I look what x1 is, and it is negative 1. So I'll just put in parentheses negative 1, like that. Okay, so then I'm going to work this out. I'll do the top first, then the bottom. 5 minus 5 is 0. And on the bottom, we have 6 minus negative 1. A trick you can use is back to back. When you have negatives and a minus sign back to back, that becomes a positive. 2 negative signs make a positive. So this can really just change to, instead of minus negative 1, it's just plus 1. Okay, make sure you understand that back-to-back negatives make a positive. So this is just 6 plus 1, and that is 7. And then lastly, you just work it out. 0 divided by 7 is 0. So that tells me that this right here has a slope. These 2 points, when plotted, have a slope of 0. And if you think, well, if it has a slope of 0, what type of line is it? And hopefully you remember from a few slides ago, a slope of 0 means you have a horizontal line. So if you were to plot those points on the coordinate grid, you would see it would be like this. It is horizontal. Okay, so let's look at the next one. Again, we're using that same equation, y2 minus y1 over x2 minus x1. And again, you label those the same way. We have our first number in each ordered pair is my x, and my y is my second, x, y. And again, you can just do x1, y1, x2, y2. So then we just start plugging them in. Equals my y2, if I look over here, is 2. So on the top, my first thing I plug in is 2 minus, remember write minus first, and then check what your y1 is, 6. So 2 minus 6 goes on top. My x2 is 4 minus my x1, which is also 4. I'm going to work this out. The top part, 2 minus 6. 2 minus 6 is negative 4. 4 minus 4 is 0. And then negative 4 divided by 0, anything divided by 0 is undefined. So in this one we have a slope that is undefined. So again, if you were to plot those points, that should tell you that since we have a slope that is undefined, that would be a vertical line when it is plotted on a coordinate grid. And again, those happen to be ones that worked out to be 0 and undefined, but you work those out the same way, even if it works out the correct way to give you actual slopes. You might get slopes that are 3/4, you might get slopes that are 2, you might get slopes that are 1/2, whatever. That's how you work those out. You use this equation, plug in your points after you've labeled them, and then you just work out the math. You do the top, do the bottom, and you can divide or reduce if necessary. So you also might be given a table and be asked to find the slope from that. You're doing the exact same way. Okay, don't let the table throw you off, because here we're given 4 different points. Okay, but all you have to do is pick out 2 that you want to use. Doesn't matter. So this is your x's, these are your y's. So 1 goes with 8, 4 with 6, 7 with 4, 10 with 2. You just pick out 2. Again, it doesn't matter which ones, you're going to get the same answer no matter what combination of 2 you pick. I'll just pick the first 2, 1, 8, 4, 6. So those ordered pairs are 1, 8, 4, 6. You're just pulling those straight from the table. Because then you're going to do the same thing. You're going to use your slope equation. y2 minus y1 over x2 minus x1. And I'm going to label these. Again, x goes first, y goes second, x, y, and then you just 1, 1, 2, 2. And then I'm plugging into my equation. My y2 is 6, so on the top I have 6. Bring over my minus sign. y1 is 8. Alright, we have the top figured out. Then we plug in the x2, which is 4, minus the x1, which is 1. Then we're just doing the math. 6 minus 8 is negative 2 over 4 minus 1 is 3. And that's it. Once you have that and you see that this fraction cannot reduce, that is your slope. Negative 2/3 is my slope of that. And again, if you were to plot those points on a coordinate grid, see my line, and work it out using rise over run, you'll also get negative 2 over 3. It's the same thing. And you'll also get negative 2 over 3 if you use 7, 4, 10, 2. If you use 1, 8, 10, 2. Any combination of those, and you work it out correctly, you'll get the same slope. Okay, so negative 2 over 3 is your slope for that one. So I want you to try this one on your own. Okay, I'm running out of time. Hopefully you pause the video and try this. I'm going to go ahead and write these to get ready to work it out with you. Again, you can choose any combination of them that you want. I'm just going to choose the first two again. Okay, so I chose the first two. This is x1, y1, x2, y2. And I'm going to, again, just plug them into my equation. My y2 is 5, minus my y1 is 2, my x2 is 3, minus my x1 is 1. Once they're plugged in, you just work out the top, work out the bottom. 5 minus 2 is 3. 3 minus 1 is 2. Here's one thing I do want to mention. With slope, most of the time it's left as an improper fraction. You don't want to change this to 1 1/2. Okay, this is your final answer. 3/2 is your slope. That's the way you'll see it in equations and in problems. So 3/2 is your final answer. That is your slope using that table. Okay, hopefully that helped you. Hopefully you understood how we're breaking down and using slope. Remember, on a coordinate grid, main points, coordinate grid, you use rise over run. Okay, you can just count how many up or down you're going and put that in a fraction over how many left or right are you going. And then also, this is a very, very, very important equation or formula to remember. y2 minus y1 over x2 minus x1. That will be used a lot. Have to get that locked away from memory. Okay? So thanks for watching. Hope that helped.